Hello everyone, hope you all are doing well and you are going through the videos which we are sending and you are getting benefited from it. Okay, so in this video we will continue with the new topic of our chapter 2, which is remainder theorem. Okay, and in previous videos we have learned about very basics of the polynomials, means what are algebraic expression, what are polynomials, what are types of polynomial, what is the degree of the polynomial, what is the value of polynomial at some given point of given point or given value of variable, and what are the zeros of a polynomial and how to find zero of a linear polynomial. Okay, these are the things which we have studied in the previous videos which I have sent from this chapter. Okay, now in this video, we will deal with new topic, which is remainder theorem and division of a polynomial, which will help you to solve questions of exercise 2.3. Okay, and along with this, you have to go through, you have to practice exemplar questions also. Exemplar questions are given in the textbook itself, and its solution is also given with full explanation. Okay, so now let us start. Okay, before understanding this remainder theorem, we need to understand what are division of polynomial and what is this division algorithm. Okay, see, we know this condition when we divide some number by other number. Okay, dividend is what? Dividend is the number or whatever you can say polynomial which is being divided. Okay, dividend is the number which is to be divided. Divisor is the number which will divide the dividend. Okay, and after this dividend and divisor, quotient is what? Quotient is the number which we get after dividing. Okay, dividing the two numbers. Suppose we are dividing 20 by 5. Okay, 20 is the dividend, divisor is the 5, and after dividing 20 by 5 we will get some number. Okay, means 5 will be divided by 20 will be divided by 5 4 times. Okay, so this 4 is the quotient, means 20 divided by 5 is equals to 4. This 4 is the quotient, and after getting divided, here we get remainder 0. Okay, so the left out number which further cannot be divided is the remainder. Okay, now in terms of polynomial, we will assume these polynomials as, see, px is or will be the dividend polynomial, gx is divisor polynomial, qx means quotient which we get after the division is quotient polynomial, rx is the remainder polynomial. Okay, remainder means whatever will be left out and will not be further divided, which we cannot divide further, will be the remainder. Okay, now if we divide polynomial in terms of polynomial, just understand, if we divide polynomial px by gx, then px is getting divided, no? So px is the dividend, it is being divided by gx, so gx is the divisor. Px is equals to gx into qx plus rx, means if we divide a polynomial px by polynomial gx, then we'll get two more polynomials as quotient polynomial and remainder polynomial. Okay, if this is the dividend, this is the divisor, then this is quotient and this is remainder. And this algorithm is px equals to gx into qx plus rx. Dividend polynomial is equals to divisor polynomial into quotient polynomial plus remainder polynomial. Okay, this was the division of polynomial. Okay, this we will understand by taking one example from the textbook. Okay, suppose we have to divide px. Px is equals to x cube plus 1. Okay, degree of this polynomial is what? 3. And we have to divide px by x plus 1. Let us understand one important thing about this division, that degree of the dividend polynomial must be or should be always greater than the degree of divisor polynomial. This is the divisor polynomial, okay. Px is dividend polynomial, its degree is 3. This is divisor polynomial, means gx is its degree is 1, means degree of px is greater than degree of gx, divisor, okay. Now let us see how to divide this. Suppose this is the px and we assume this as gx, divisor polynomial, gx is x plus 1. Then by long division of polynomials, if we divide px by gx, we will get some two more polynomials, qx and rx. Qx is the quotient polynomial and rx is the remainder polynomial, okay. Now let us see how to divide. See, by long division method of the polynomials, see, x cube plus 1, x cube plus 1 is the dividend, and it has to be divided by x plus 1, which is divisor, okay. Now see, first term of divisor, first term of dividend is x cube here, first term of dividend is x cube, and first term of divisor is x, okay. Now we have to get such a variable, we have to multiply x by such a variable or such a constant or whatever you can say, such a number, so that we can get x cube, okay. So with what we will multiply x to get x cube? X will be multiplied by x square. If we multiply x by x square, then we will get here x cube, okay. X multiplied by x square is x cube, okay. Now what we have done, we have multiplied first term of the divisor with x square. Now second term of the divisor also should be multiplied by this x square. Now 1 multiplied by x square is x square. Here we will write plus x square, okay. What we have done, we have multiplied x with x square or by x square to get first term of the dividend, okay. First term of the dividend is x cube. So x multiplied by x square is x cube. Here we have written x cube after multiplying. Now second term of the divisor also must be multiplied with this x square. So 1 multiplied by x square is x square plus x square you have written. Now this was x cube and plus x square. So we need to change the sign. Why we need to change the sign? We have to cancel this first term of the dividend, okay. Now after changing the sign, this plus x cube will become minus x cube, okay. So x cube minus x cube will be cancelled out and we'll get here 0. Here nothing is written, means it is 0, okay. Now after changing the sign of plus x square, it is minus x square, and we don't have any term in the dividend which we can subtract or add with x square, okay, because its degree is 2, means its power is 2. Sorry, I'm saying degree, its power is 2, and we don't have any term in the dividend with power 2, okay. So x square or minus x square will be written as it is downside, okay. We have written here. Now we don't have any term of x also, so we will leave the place, we will leave some space for x, okay. X square we have got from here, and there is no term of x, okay, in the dividend, so we'll leave some space for that. Now constant term is there in the dividend, so we'll write the constant term as it is. Now this is the new dividend of ours to be divided. This is the new dividend, and first term of the new dividend is what? X minus x square. First term of dividend is minus x square. Now we have to get such a number to multiply with x, okay, means x will be multiplied with such a number so that we can get minus x square. Then what we'll do, leave this first term of the quotient, we have get minus x square. Now what we'll do, we'll multiply x with minus x, okay. So x multiplied by minus x is what? Minus x cube, sorry, minus x square, okay. X multiplied by minus x is what? minus x square. Now second term of the second term of the divisor also is to be multiplied. Second term of divisor is plus 1. So plus 1 multiplied by minus x is what? Minus x. Okay, minus x. So what we have done, we have multiplied the divisor by minus x to get minus x square here. Okay, why to get minus x square here? After getting minus x square here, this minus x square and this minus x square will be cancelled out when we change the sign of this minus x square. Okay, now our new dividend was minus x square plus 1. Okay, after multiplying plus x with minus x, we have got minus x square, and plus 1 multiplied by minus x, minus x. Okay, now we need to change the sign. These both the terms are negative. After changing the sign, it will be plus x and plus x, plus x square and plus x. Now minus x square and plus x square will be cancelled out. Here is the 0, here remaining is the 0. Okay, nothing is written means 0. Now minus x has been changed to plus x. So plus x you will write here as it is, and the remaining is constant term, which is 1 plus 1. Okay, now first term of the divisor is x as it is, and our new dividend is x plus 1. Okay, our new dividend is x plus 1. So first term of divisor is x and first term of dividend is also x. So what we'll do to get x here, we will multiply x with plus 1. So write here plus 1. X multiplied by plus 1 is plus x, and then second term of divisor is to be multiplied also. So plus 1 multiplied by plus 1 is plus 1. Okay, our new dividend was x plus 1, and after multiplying this divisor with plus 1, we have got x plus 1. Okay, now change the sign, because we have to change the sign to cancel out. Now this was plus and this is also plus. So to cancel it, we have to change it to minus. So it will become minus x and it will become minus 1. Now plus x minus x is 0, and plus 1 minus 1 is also 0. Okay, so remainder what we have got here, remainder is 0, and quotient is x square minus x plus 1. First term of the quotient was x square. Why x square? Because x multiplied by x square is x cube. Okay, and if we have multiplied the first term of divisor, then we have to multiply second term of the divisor with x square. Now our new dividend was minus x square plus 1, and first term of the divisor is x. So to get minus x square, what we have to multiply it with x. Okay, now this x will be multiplied by minus x to get minus x square here. Again we'll do the same, we'll multiply other term of dividend also with minus x to get minus x. Okay, now new dividend was x plus 1. X plus 1 was the new dividend. So what we'll do, we will multiply first term of dividend is 1, no? So we'll multiply x with 1 to get x here. Okay, so this way you will divide, and this is called long division of polynomials. Okay, we have divided x cube plus 1 px by x plus 1, which is gx, and we have got quotient a new polynomial and remainder 0. Here rx is 0, remainder polynomial is 0. So this was the division of the polynomials. Now after understanding this, we will move to remainder theorem. What is remainder theorem? Okay, let me tell you in easy words what is the use of remainder theorem. Okay, means we apply remainder theorem when we don't perform long division of the two polynomials actually. Okay, means without performing actual division of the two polynomials, we can get the remainder after which will get dividing the two polynomials. Okay, means remainder theorem is what? Remainder theorem gives you the remainder of division of two polynomials without dividing it actually, without dividing those two polynomials actually. Okay, see, let us see the statement of this theorem. Let px be any polynomial of degree greater than or equal to 1. Means we have a polynomial and its degree can be 1 also or greater than 1 also. Means degree can be 4, 5, 3, 2, 6, 10, 11, whatever. Okay, we have some polynomial of degree 1 or greater than it, and let a be any real number. Means a is any constant number. A is any constant number. Okay, we have a polynomial px with degree greater than 1 and a is any real number. Then if we divide px by a linear polynomial ax minus a was any real number. Okay, a was any real number, and if we write as x equals to 1, and then we transpose this, sorry, x equals to a, and then we transpose this a to the side of x, then we will get x minus a equals to 0, which is a linear polynomial. If px is divided by a linear polynomial x minus a, then the remainder of the division of px by gx will be PA, and PA is what? PA is the value of polynomial at x equals to 1. Okay, now let us understand this with some example. Suppose we have a polynomial x to the power 4 plus x cube. This is px. Okay, px means dividend polynomial. Dividend means this polynomial has to be divided. If we have a polynomial px equals to x to the power 4 plus x cube minus 2x square plus x plus 1. Okay, and this px is to be divided by gx. Gx is what? Gx is x minus 1. So first of all, what we'll do? We will equate this gx to 0 to get value of x, value of variable. From gx we will find the value of x. Okay, and this value of x will put in px, and that value of px at x equals to 1 will be the remainder. Okay, see, gx, what we have done? Px is being divided by gx. Px is dividend, gx is divisor. Now from the gx we will get the value of x. How will get the value of x? Equate gx to 0. Gx is this, so gx equals to x minus 1 equals to 0. If x minus 1 is equals to 0, then if you will transpose minus x to RHS, it will give us x equals to 1. X equals to 1 is the value of x, value of variable. Okay, and if you put this value of variable in place of x in px, then it will be p1, and this p1 will be the remainder of division of px by gx. Okay, means without performing that long division that I have explained before this, you can get the remainder. Okay, when we'll do some questions, you will get it clear what is the use of remainder theorem and why, how to apply this. Px, when px is divided by gx, okay, that is px is to be divided by gx, then the remainder will be value of polynomial at x equals to 1, and from where we have got this one? We have got this one by equating gx to 0. We have got value of x equals to 1 by equating this to 0. So this is the remainder theorem. Okay, the remainder theorem is that if we are dividing the two polynomial px and gx, then without performing actually division of those two polynomials, we can get the remainder. Okay. Now let us understand two more terms which is not given in the book. What are multiples and what are factor? Because questions are given in exercise 2.3 to check whether the given polynomial is multiple of this polynomial or not, or this gx is factor of px or not. Like this questions are given. So let us understand what are multiple. See, px is multiple of gx. Px means dividend polynomial is multiple of divisor polynomial if and only if px is getting divided by gx completely, leaving the remainder 0. It means what? When you divide the dividend polynomial by divisor polynomial and remainder comes out to be 0, then px will be called as the multiple of gx. Polynomial px will be multiple of polynomial gx. Okay, like 20 is multiple of 4. Why 20 is multiple of 4? Because when we divide 20 by 4, है ना, 20 is getting divided by 4 completely, leaving the remainder 0, and quotient comes out to be 5. Means 20 is multiple of 4 because 4 is dividing 20 completely, leaving the remainder 0, or 20 is getting divided by 4 completely, leaving the remainder 0. Okay, so 20 is multiple of 4. Okay, now understand what are factors. See, factor of polynomial px, dividend polynomial px. Suppose gx is some gx is some polynomial and gx is divisor polynomial. Okay, then gx is will be, or gx is the factor of polynomial px, which is dividend, if and only if gx divides the px completely, leaving the remainder 0. Here if you understand, see, 4 is dividing 20 completely, leaving the remainder 0. It means what? 4 is the factor of 20. Okay, and vice versa, 20 is the multiple of 4. Okay, if px is divided by gx, px is dividend, gx is gx is divisor, and remainder comes out to be 0, then gx will be called as factor of px. Okay, so this was the basics of the topic which we have to understand to solve exercise 2.3, division of the polynomial, remainder theorem of the polynomial, and what are the factors and multiples. In the next video, which I'll attach with this, we will solve some questions from exercise 2.3. Thank you.